So we've talked a lot about this data pipeline and the relationship between data and AI. But I'll tell you from personal experience, with a lot of customers that I talk to, even though there may be an understanding of the relationship between data and AI, model training, inference, etc., for a large part, the organizations that handle these are bifurcated, right? You have traditional big data analytics types organizations that are involved in the data prep side of things. And from a model training and model inference standpoint, the folks that are in those industries, a lot of them come from academia, right? And in academia, you don't have the time or the grant money to do data prep and model training and all of those things. So typically you're dealing with well-known data sets, right? And what happens though is that if you are looking to deploy AI for high value use cases, right? So I'm going to take just a quick second and talk about how AI is being used in the market today. And there was actually a great paper that was done by Deloitte at the end of, or a survey that was done by Deloitte at the end of last year that put a focus on this. So 70 to 80% of the usage of AI today is based around efficiency and cost savings type use cases, right? Only 30% are looking at AI for the higher value, innovative use cases, putting AI into your services that you offer or using it to develop new services. So the thing about this whole data picture is that to get into those higher value use cases, just like Kamal was saying just a second ago, to get into those higher value use cases, you need to be in charge of your data. You need to understand the provenance and lineage of where that data comes from. So to analyze this better, one of the things that we've done at VAST, and this is a slide that we've built after talking to many of our customers, is break down the movement of data from data capture and raw collection all the way through the data prep phases, training, quantitization, and then model serving, right? One of the things you'll notice is, of course, the amount of data that you need does shrink as you go across here, but the story comes back full around, right? Because when you get to the model serving stage, now you are auditing, you have to track all of those prompts and responses that you're getting from the inference that you have out there. This is the other unique thing about AI and AI pipelines. Traditionally, enterprise users are very used to a linear flow when it comes to deployment of software, right? You deploy software, it does a thing, you discover some issues with it, you address the defects or the bugs in it, and then you can roll out the next version. AI is not like that, right? AI is non-deterministic and therefore experimental in nature, right? So when you go across this pipeline, when you get to the end and you deploy AI, when you're working on your next model, you actually need the inputs from that model serving inference phase, because they are now going to affect the way you evaluate your trained model. It's not guaranteed that your new model is necessarily going to work better, right? Or give more accurate responses than the original model that you'd fed into it. So the movement of data and zero trust and lineage across the space is a tremendous challenge to deploying AI for high value use cases at scale, right? Now, the way we traditionally deploy AI workloads doesn't help that problem. Okay, so you guys were talking a minute ago about trying to figure out this balance about which functions you run on the vast platform versus which functions you run externally, right? So the traditional way of doing things is sort of the worst case scenario, right? Data comes in, you store it in an object store. If you want to consume it through NFS, if you want to do any sort of processing with NFS, you actually have to copy that data so you can process it with NFS, right? You store this in some sort of a large file. If you want to scan that large file, you have to put it into a high memory server, right? You have dedicated storage that you deploy solely for the purpose of checkpointing, right? And then when you do your inference, once again, you're creating these massive files that you have to store, move, and manipulate. So what VAST does, and I'm going to get into that in just 1 second here, but what VAST does is, and the capabilities we have are intended to simplify your life in that space. Now, it's not 100% a recipe we give you, right? Yes, you can run certain functions on our platform. You can run those same functions off our platform. When do you run them on our platform? When do you run them off our platform? That's going to come down to a system architecture standpoint question, right? The more data adjacent a function is, the more it makes sense to run that on the platform, right? Every time you have to move a bunch of data to a server to analyze it or study it, if you can do that function closer to the data, then that gives you an advantage in terms of your overall end-to-end processing. Make sense? So highlight a couple of things real quick, and then I'm going to bring Sandeep up. So first of all, data space. We talked about this a few weeks back with Keith. One of the big challenges with AI pipelines is the compute resources that you need are distributed all over the place, yet you want to have access to common data with all of those different compute resources. So the vast data space enables you to store your data in a single location, right? And then have all clusters have visibility to that data. We talked about the data store and our ability to present data to GPUs at a very high rate of speed. And when needed, even use that same storage for checkpointing when you're doing your AI training and model development. We talked about data. We have something called a database, right? What we do with the database is we store data in a structured manner on the platform, right? Common use case for data preparation, or common tool for data preparation, is Spark, right? When you're doing data preparation, sometimes you have queries that are data intensive. Other times you have queries that are mathematically intensive. So what VAST has done is, especially for the data preparation phase, we've built an integration with both Spark and the VAST database, where you can push predicates and push data-intensive functions down onto the platform. But then you also have an integration with Rapids. So for the computationally intense workloads, you can leverage GPUs to do those, right? And you're also going to be hearing from us, and John alluded to it, the ability to run Spark queries and have a Spark execution engine on the platform itself. Now, why would we do that? It's not because we think all Spark should be run on the VAST data platform. But if you think about those scenarios where you have one function that you need to do, and you need a little bit of compute to do that, why should you ship your data somewhere else just to do that one function and then write the data back down to VAST, right? So, and then we've talked about the data engine, right? Functions and triggers on the platform that you can do as a part of your inference and your model serving time. There's functions and activities that you can do during the data preparation phase. Once again, always trying to find this balance between what work am I going to do? When I look at my entire AI pipeline, what work am I going to do that's data adjacent and makes sense to do on the data platform versus what are some of those higher order functions where I'm doing things that are more computationally intensive and are best leveraging a GPU or some other capability.
I got a question.
Yeah.
In the risk of slowing you down and taking
No, we're good. We're good.
complete right turn in
Yeah.
your conversation. Up until the whole presentation, up until this, I was thinking the persona you're talking to is the storage and the infrastructure admin to kind of make sure that it's running the right tech stack on where they need to be. Totally get that. Until I saw this.
Okay.
And leading up to this, I was thinking that it was that infrastructure person as well as the data scientist.
Sure.
Then I saw this, right? And then I was thinking DevOps when
Correct.
I saw this. Well, so what I haven't heard so far, and I have heard the competition, is DevOps or dev-ready infrastructure. I haven't heard any of that messaging so far. I'm curious where you're going with that.
I know exactly it, right? So what we recognized, and this is going to be a great introduction to Sandeep here, what we realized in talking to our customers is we have a great platform. It has a ton of different capabilities. What we don't have is a way for people to use the technology in an operationally efficient way, right? So to your point, right, there's this merger of, right, so let me take a half step back. Let's think about the traditional HPC scenario. Traditional HPC scenario is a scientist who gets a period of time on a set of GPU hardware. They queue up their jobs using generally a tool called Slurm, right? Those jobs run at 100% GPU utilization for the entire period of time that they're using it, and then they turn over their keys to a different person. That is not enterprise AI, right? Enterprise AI has many different competing priorities, often which require preemption. They require a DevOps model, but that DevOps model merged with the experimental nature of AI, right? Because AI isn't like DevOps where I can just commit my updated model to the code base and that's instantly going to get promoted. No, that you're going to make a change to your model. It's going to get experimented against. It's going to get evaluated with different data sets. And the determination is going to be made as to whether I want to use that model or not, or maybe I want a different model, right? Maybe that was a dud.
And possible multiple times a day.
Exactly. One of the things we realized is we needed to, in addition to infrastructure partnerships and technology partnerships around NVIDIA and things like that, we needed an operational partner in the mix. And so today, I'm very glad to announce that Sandeep is joining us. Our partnership with Run AI was actually something we announced in the middle of February, but we felt that Run AI was very key to completing this story, and so we wanted to have Sandeep join us today.
Thank you, Neeloy. Appreciate it. Thanks for having us.
All right, so let's dive into it. We were just talking about Slurm and Kubernetes and AI workloads and all the challenges that enterprises face. You guys live and breathe this every day, so tell us your perspective.
Sure, yeah, just by way of quick introductions, Sandeep Brahmarouthu, I run partnerships at Run AI. We're effectively a GPU resource management platform for AI workloads, right? As Neeloy talked about, GPUs are obviously very, very important for AI workloads. We're seeing a ton of demand working with partners like NVIDIA and others. And it's become kind of a de facto platform for a lot of model building, all the way from data preparation to model building, to model training, obviously, to inferencing, right? And we see a challenge now in the marketplace today, which is how do you get access to that really, really scarce compute, right? Especially as you see AI really starting to take off. There's a lot more data science teams that are popping up across organizations. And they all need access to compute. They need access to compute to be able to build models, to train models, and the entire life cycle, right? We're seeing the huge challenge there in terms of how are enterprises providing access to that compute so that they can innovate faster, get better ROI on that infrastructure, and provide value back to the business, right? So lots of cool stuff that we're seeing in that in terms of how, together with Vasta, we can help our customers in that, helping them really get their models out to market quicker and get the best ROI possible.
Yeah, so it's a challenging problem from the user-based standpoint, right? So you have your AI folks, scientists and researchers who are used to tools like Slurm, right? And that's sort of their comfort space, safe space. You have data scientists who have been spoiled to some extent by, AWS, GCP, Databricks, Snowflake, right? They're used to those tool sets and have built pipelines and entire tool chains focused on that particular world. And then we introduced Run AI, which is a Kubernetes-based platform. And as we know, Kubernetes is very good at managing resource contention and resource management in enterprise environments, but it's different than people are used to. So how do you help people sort of get over that hurdle, and what are some of the things that you guys are doing to help people with that transition?
Yeah, it's a great question. I mean, obviously, Kubernetes is a de facto sort of an orchestration platform for a lot of different workloads, right? But it wasn't really built for AI-specific workloads. And when I say specifically, some of the things around how do you better schedule AI workloads most effectively, talking about the entire life cycle. How do you sort of get most out of that GPU processing power at the fractional layer, what have you? So that's where Run AI sort of comes into play, is that we've built a software platform that effectively runs on top of Kubernetes. And we were bringing in additional enhancements to that Kubernetes layer, specifically to run AI workloads for GPUs, right? So as an example, we built extensions into the Kubernetes to provide advanced scheduling capabilities. So ability to schedule workloads on GPUs in a much more efficient way. Being able to do over-provisioning of GPUs, being able to fractionalize the GPUs. So lots of sort of the scheduling capabilities, that's extremely important, especially when you have different data science teams are running different types of AI workloads. Some may be running training workloads that they require a lot of GPU power. Somebody else may be just building a data model or model building on a Jupyter notebook as a service. They just need a fraction of a GPU. Somebody else may need running a whole bunch of concurrent jobs, doing inferencing, right? So how do you sort of manage all these different workloads? How do you schedule those in a much more efficient way, right? That's sort of, so we're bringing that scheduling capabilities to Kubernetes. So especially with generative AI, we're seeing a lot of these workloads being built on top of containers on Kubernetes, right? So it's really important you have that advanced scheduling capabilities so that you're effectively democratizing access to compute in an efficient way, so that they can build these models faster, much more efficiently, and get that ROI.
Yeah, no, absolutely. So Keith, when we talked a few weeks back, you'd asked us how we solved the data gravity problem, right? And the reality is we solve it in several parts, right? Yes, the data space lets everybody know about what data is available. But to your point, data is heavy. Data has to be moved, and it can't be moved instantaneously, not without, crazy amounts of bandwidth. So in partnership with Run AI, what we're now able to do is now we have the GPU availability and scheduling function, which knows the right time to land a workload in an environment, integrated into the Vast Data Platform, which knows how to get, which has the data. And so now you can get the right data to the right location in time for the job, right? And the end result is the CPU utilized, or the GPU utilization, the GPU utilization you're now able to see by properly scheduling your jobs. And I say properly, meaning having a layer that understands the business requirements, right? That understands that if you have a surge in inference workloads, that those can be used to preempt some training workload that may be being used to improve the model. But you know what? Improving the model will come tomorrow. I've got to do more model serving because I've got a user demand, right? So that's really how we're bringing all of the pieces together, both the technical capabilities as well as sort of the operational capabilities needed to enable customers to use those, data platform capabilities most effectively.
Yeah, I would love to, we can do this offline. I would love to go through kind of the power of the business logic. A good friend of mine has a saying that you don't give a app with limited business value unlimited resources.
Right.
So I would love to just understand, what happens when two inference related apps are contending for finite resources, and how can I rank the priority of those apps? And from a data movement perspective, orchestrating when the time that I do have to move data, how to do that in conjunction with scheduling the actual workload.
Yeah. Yeah, no, absolutely. One of the things that we're going to be releasing at GTC, actually around the same time as GTC, is a set of blueprints in combination with Run AI. Some that are focused on enterprise users and some that are focused on service providers. Not going to claim that we've got all the problems solved, but the blueprints give a great foundation to build some of those capabilities on top of it, right? To sort of, okay, what are the right ServiceNow integrations? What are the right, other platforms that I need to integrate with that can help inform, Run AI on, hey, what decisions should I be making, right? I don't know if you want to say.
Yeah, I was just going to add to that, right? It's also something that we hear a lot from customers, which is, especially as you see proliferation of different data science teams working on different, models and applications, what have you, right? Another big problem that we see with the enterprise is that IT is sort of losing visibility into who's actually doing what from an AI perspective, right? How do you sort of consolidate that infrastructure from an AI perspective and apply the right policies so that the people that are working on high priority projects have guaranteed access to compute when they need them versus somebody else maybe just doing something that is maybe not as priority, right? So together with Vast, sort of providing kind of a blueprint for customers so that they can apply policies within our control plane so that people that require the compute when they need it, right, and prioritizing the different types of jobs get the guaranteed access to that compute when they need it.
Yeah, I talked to this was 3-4 years ago, or maybe not that quite that long, maybe 3 years ago. Talked to the department chair of AI at Georgia Tech. He was one of the first people, especially one of the first researchers to get an H100. And he had this practical problem of, I have all these researchers.
Yeah.
How do I carve up and prioritize workloads with this super valuable asset that's very finite? And, it's a tough problem.
And that's actually a bread and butter use case, right? That is exactly the use case that we see is the resource contention, right? Number of data scientists, compute, right? And you're seeing a lot more people working on AI workloads. And so how do you kind of maximize efficiency of that together with Vast, not just from a compute perspective, but also from a data standpoint?
All
right?
of it, yeah.
At the end of the day, you need data to be able to build those models, train those models, and then be able to use that for inferencing as well.
I would take Keith's question a little bit further and echo what Keith's talking about, but take it to the maturity level of organization.
Right?
So love to be part of that follow-up.
Sure,
There's a lot of
absolutely.
questions that I know we don't have time to talk
Yeah.
about right now.
No.
I mean, I think this is also like indicative of like what we see in the market today is that, and this kind of goes back to the blueprints, right? Like we're seeing a lot of customers saying that, hey, how do I actually get started with this, right? Because I have all these different teams doing different pockets of like AI compute, some are running in the cloud, some got their own.
Around how are you letting organizations know, how do you get them started?
Yeah, it's a great question. I mean, I think we have a lot of organizations that are getting started, right, with our platform. I think there's a lot more we can do as
Friction there.
Oh, there is. I'll just say one parting thought, and then I'll turn the stage back over to John here. I actually think the journey everybody went through with hybrid cloud was a good thing in terms of, the shadow IT took over. That genie escaped from the lamp, right? And by the time you were done, to try and justify hybrid cloud strategy or a cloud portal to sit in front of all of that, it was hard to justify the ROI, right? You're disrupting everybody's world. We actually have, now that platform engineering is involved and the concept of an internal developer portal exists and things like that, we now have the ability to help organizations create this internal developer portal, right? And basically be AI ready, even if all the services they're consuming are from outside parties, right? They may not have any GPU estate, but how do we help them become more AI ready? And so, yeah, definitely would love to continue that discussion. All right, we are way over time. Thank you so much
Thank you, Neeloy.
for the support and partnership.
Thanks, Sandeep.
And,
Thank you, John.
All right, we're going to just close up summary. I do also think in that AI ready theme, I think there's a fallacy that people think that just putting up a bunch of GPUs is like a silver bullet to getting into the AI game. But as you guys know, data is really the fuel for AI, and I would argue that it's not just data; it's high quality data is really what matters. And I think making organizations, whether they're ready to do the science of AI or not, there is a journey they have to start in getting their data AI ready, regardless, right? If they want to get down this road. So summary, 3 slides. We are, hopefully through today, you understand we are we were never intended to be a storage only company. We are finally starting to unveil a lot of this to the world. And this is kind of our vision. We've got these great partnerships that we're working with. Thank you again to all of our partners that were here and for the announcements that that we made today. You can find more information on our website and all of the social media stuff that I'm not on. So, and then lastly, we will be, VAST is going to be, I know Run AI is also going to be, I'm sure Supermicro and everybody else will also be at GTC in March later this month. Please come by, say hi. You'll see live demos of a lot of the stuff that we talked about today with some of our partners in tow as well. So with that, we thank you all very much for your time.